So is it started? Recording is started.
Yes, sir. Yes, sir.
Yeah. So let's start with the IPv4 addressing. So the contents of this module, like what are the different IPv4 addressing? There is address structure. What do you mean by unicast, broadcast, multicast? Types of IPv4 addressing, network segmentation and subnet of IPv4. So these are the points we are going to discuss in the today's lecture. So there are a lot of the students have a fear of doing and subnetting and supernetting. So we will try to remove that all fear, and let me try to do this actual example and try to solve how we can able to do the subnetting for any particular company. So IPv4 address structure, everyone knows about it. I will not spend much more time. I hope everyone knows 32-bit address stream separated by the dot, that is known as octet. So that is 192.168.10.10. So that is, we can say, the 4 bits. That is the 4 different octets will be there. 4 different octets. Yeah, sorry. Let me start. Yeah. So 32-bit IP address, that is, what is the size of each portion? 8-bit. Size of each portion 8-bit. That is represented from 2 raised to 0 to 2 raised to 7. Hello?
Yes, sir.
Yeah, in this
Yes.
particular module, all activity you have to do. So I request everyone, please be ready with a paper and pen, notebook and pen. Okay, so that you can yourself able to try the things and get confident about that IP addressing. So 2 raised to 0 to 2 raised to 7, 8 bits will be there. What is the maximum final value of each octet?
255.
255. So it will be 255.255.255.255. That has been, we can say, the possible in highest range. That is maximum value possible in every octet. So it is 8 4s are 32. So total size of this particular IPv4 is 32-bit. So next, that is subnet mask. That is, what is the use of subnet mask? To divide the IP address into 2 portions, that is the network and host portion. It divides the IP address in 2 portions, network and host portion. Is it clear? Is this clear? So what do you mean by divide the IP address in 2 portions? The number of ones in the subnet mask, carefully listen, number of ones in the subnet mask will going to decide number of bits from the IPv4 address take as it is to form a network portion. बराबर है? Whereas the 0 bits of the subnet mask replace all the IPv4 address bits to 0. Replace all the IPv4 address bit to 0. So if you observe here, all the 3 octets we have all ones. So means for our first 3 octets, we have to take the values as it is. So it will be say as 192.168.10 and replace all 0 bits in the subnet mask portion. That is the positions of all the 0 bits in the subnet mask. Their respective position in the IPv4 address should be made as 0. So the network address will become 192.168.10.0. So the portion where in a subnet mask we have 0, that portion we have to take as it is at 0 in the network, whereas whenever we want to have it as host, whenever we want to talk it about host, this all 0 bits will be considered as 1 and that will say that number of hosts may exist in that particular network, that is 255. Network and the host portion. Network portion and the host portion. So we can say here, for this particular IP address, we can say this IP address belongs to network 192.168.10.0, having the host ID in the range from 192.168.10.0 to 192.168.10.255, 192.168.10.0 to 192.168.10.255 number of hosts. In that network, one of the IP address is given by this 192.168.10.10. Okay, the role of subnet mask is to divide the IP address into a network portion and the host portion. Number of ones in the subnet mask decide number of bits from the IP address to be considered as a network portion. Number of bits in the IP address to be decided as a part of network portion. Whereas number of zeros in the subnet mask will replace the values in the IP address to 0. Will replace the bits in the IP address to 0, and the resultant will be an network address to which this IP belongs. Network ID to which this particular IP belongs. Is this clear? Any doubt on this slide? It is very much important. So for performing this, we are doing an AND operation. Then we are going to do a binary, and then in the binary we perform the AND operation. So without doing that, that is okay. The AND operation for बच्चों के लिए ठीक है. It is okay. That is been that we are going to AND, and then we can have a network ID. Then we are going to OR, then we can have the first ID. No, we will not do in that way. This is what we can say proper way. Number of ones directly going to decide the value. Number of ones going to decide the value. Is it okay?
Yes, sir.
Is this clear?
Yes, sir.
Is this clear? Okay, so I can write here. So now I will tell you what is the use of this Excel sheet. 192 is been given as 128, है ना? Plus 64, that is 192. All other bits are 0, 0, 0, 0, 0, 0. Let's go to 168. We have to have 128. Then we cannot have 64. That is goes to 192. We can have 32. That goes to 160. We want 8 now. So that is here as 1. 168 been done. All other bits to 0. Is it okay? 10
Yes.
we want. So 0, 0, 0, 0, 8 plus 2. So that is 1, that is 8 plus 2, not 4. 2, that is 10. And again 10, so that is same. 0, 0, 0, 0, 0, 1, 0, 1, 0. That is 10. Is it okay now? Is this okay? This is what IP address. बराबर है? Its respective subnet mask whenever we want to find its respective subnet mask, let's suppose all are written as 1. Correct? Then wherever the 1 is present in the IP address, that will be replaced as 1 because AND operation is there. बराबर है. Wherever 0 is there, it will not be get considered from the subnet mask. So what will going to happen here? It will be as it is 1 1. All other bits 0 0 0 0 0 0. That is 192. Then here again 168. So 1 1. Here it is 0. Here it is 1. Then again a 0. Again 1. 0 0 0. Then that is again all ones are there. So 1. Sorry. 0 0 0 0 1 0 1 0 10. Now here the subnet mask given is 0. So all the bits at this position will going to be 0. So that's why this is become a network ID. This become its network ID. Is this clear?
Yes,
Is
sir.
this clear? Okay. What will be the last, or we can say as broadcast ID? Broadcast ID make all host bits to 1. How we can able to say that host bits? I will copy paste here. Make all host bits to 1. So in subnet mask, the number of 0 bits going to indicate the host portion. So last octet is a host bit. So if we make it as 1, so what will become an broadcast ID for this network? 192.168.10.255. Is it correct? Is this correct?
Can you explain that thing again, sir?
Yeah, why not? Definitely. That's why it is very important. See, this is what IP address 192.168.10.10. This IP address has subnet mask as 255, 255, 255 and 0. Number of ones in the subnet mask going to decide number of bits from IP address to be considered in the network portion. बराबर है? So all 3 octets has 1. So all the 3 octet values will be taken as it is. That is 192, 168, 10. Last octet has all values as 0. So we have to take it as 0. So we are not going to take any value from the IP address. We are not going to take any value from the IP address. Whereas it is get replaced with the it is get replaced with 0. So that will become 192.168.10.0. That is network ID. Now to get the broadcast ID or the last ID of that particular network, we are going to make all the host bits to 1. How can find the host bits? Number of zeros in the subnet mask going to tell us number of host bits. बराबर है? So in this subnet mask, last octet is full having 0. So that is last 8 bits are host bits. So just make that all last 8 bits to 1. That will say as broadcast ID or the last ID of that particular block. Is this clear? Last ID of that particular block. So always remember, in the network IDs, that will become the first, that is first ID of that block, and broadcast ID will be the last ID of that block. So always number of host addresses will be available in that particular network or any block will be -2, because these two will be always been considered as network ID and host ID. That's why total number of host addresses minus 2. So how many total number of host addresses here? 255 minus 2, that is, sorry, total is 256. 0 to 255, that is 256. So here I have 256 host space. So the available host space is 254. Number of address space for the host are 254. Is this clear?
Yes, sir.
Yes, sir.
Crystal clear. There should not be any kind of confusion, please. I am ready to repeat 10 times, क्योंकि अगर ये नहीं आया तो सबनेटिंग नहीं आएगा.
सर अगर होस्ट पोर्शन में वंस रहेगा तो फिर उसको जीरोस करना है क्या?
होस्ट पोर्शन में
वंस को जीरोस एंड जीरोस को वंस ऐसा करना है.
let's suppose I make this particular field as 1. बराबर है, मैंने यहाँ पे 1 कर दिया. ठीक है, तो सबनेट मास्क क्या हुआ? 255.255.255.128. Got the point? Hello?
Yes.
बराबर है?
Yes, sir.
Which force me to consider, hello? Yeah. Which force me to consider the 1 bit from last octet into a network ID, which is already 0, so there is no change. It is 0 itself. बराबर है? But number of host bits will tend to, this should be 0. ये होस्ट पोर्शन नहीं है, ये नेटवर्क पोर्शन है.
होस्ट पोर्शन है ना सर?
I will just a minute. This is network portion, and this will be going to be a host portion, क्योंकि सबनेट मास्क में यहाँ पे फर्स्ट बिट ऑफ लास्ट ऑक्टेट इज 1. So now available number of host bits are 1, 2, 3, 4, 5, 6, 7. Is it clear? Is it clear?
Yes, sir.
7 bits are available. That is 128 host space. That is equal to 126 total available address space for the host. So can you tell me the first and last address of this block now? For this subnet mask, first address is 192.168.10.0. Last address is 192.168.10.127. Last is 127 because this bit now become a portion of network. It is not a portion of an host. बराबर है? So मैंने क्या किया अभी? By making or adding this particular, by adding 1 here, I shifted one of the host bit to a network portion. I shifted one of the host bit to a network portion. This is nothing but the concept of subnetting. बराबर है? Sir, और डिटेल में बताओ. Let we go into this. Now let me understand here. This is 0. I keep this one as 0. So this will make this bit should be equal to 1. बराबर है? So in the last octet, total address space is 256. This all 256 address space belongs to one network ID, 192.168.10.0. Agreed or no?
Agreed.
Correct? By putting this as 1, I have made 2 network portions of that same space. 256 को मैंने 2 इक्वल पोर्शन में डिवाइड किया, 128 128. Yes or no?
Yes, sir.
बराबर है? So what will be the second block? The second block will be, yes, what will be the second block? Whenever I put this value equal to 1. Is it clear? Now let me understand what will become a network ID. 192, 168, 10, 128 से शुरू होगा, 255 पे खत्म होगा. ये 0 से शुरू होगा, 127 पे खत्म होगा. So of one portion I have made two portions.
सब ब्रॉडकास्ट आईडी के इधर
Just I will.
0 आएगा ना.
Yeah, tell me.
उधर ब्रॉडकास्ट आईडी के इधर 0 आएगा ना.
कहाँ पे? यहाँ पे. हाँ.
हाँ
कहाँ पे 0 आएगा?
हाँ
यहाँ
लास्ट
पे?
बिट के.
नहीं, क्योंकि हमारा नेटवर्क आईडी अभी 1 से शुरू होने वाला है. दैट इज द सेकंड ब्लॉक. Okay, I will come to this portion again. Let's suppose a company has problem ले रहा हूँ. Please listen carefully. A company has allocated an IP address as 192, 168, 10.0 to ABC company. बराबर है? With a subnet mask as 255, 255, 255.0. ठीक है? कंपनी को मिला. Now company wants. So first I have mapped this here. So मैंने 192 यहाँ पे लिखा, 168 लिखा, 10 लिखा, and here I should put it here as 0. So मैं ये 10 निकालता हूँ. I will keep it as 10. That is no problem. Subnet mask 255, 255, 255, 0. So network ID become 192, 168, 10.0. बराबर है? Broadcast ID become 192, 168, 10.255. So the total address space available is 256 minus 2, that is 254. Is it okay?
Yes
Now,
sir.
yeah. Now next. Company has two departments of equal size. The company ABC has two departments of equal size. So this available portion of the company, they have to divide into two equal size subnet mask, two equal size networks. बराबर है? So क्या करेंगे हम? To make more networks, we will reduce the host bits and increase the network bits, क्योंकि we can't change in the third octet. थर्ड ऑक्टेट में चेंज नहीं कर सकते. दैट इज अलोकेटेड. 10 सीरीज का अलोकेशन दिया हुआ है. यू कांट चेंज हियर एनीथिंग. व्हाट वी कैन चेंज, मेरे होस्ट पोर्शन में मैं चेंजेस कर सकता हूं. आई हैव 256 एंड क्रिएट टू डिपार्टमेंट ऑफ इक्वल साइज. व्हाट आई विल डू, आई विल मेक इट एज 128, 120. Agreed? I can do changes in my host allotted portion. I cannot change the network portion. It has been allotted to me. So मेरा कोई भी नेटवर्क में आगे शुरू करूं, that has 192, 168, 10, 100%. Is it clear? ये 3 ऑक्टेट में I can't do any modifications. Is this clear? Last
Yes,
octet
sir.
का देखते हैं. Is this clear? Okay. Now what I said here. Now this is what allocated to me by my ISP provider. This is allocated to me by my ISP provider, let's suppose. And I want to make it into two equal size portion. So what I can do, so you should able to understand that whenever it is in 2:2, every bit is a half of the previous bit. बराबर है ना? 128, 64, 32, 3, 8, 4, 2, half है?
1.
Yes or no? Yes or no?
Yes sir.
Yes, sir.
So if I remove one bit from the host, it will cut down to half. बराबर है. So I have removed one bit from the host and make it as 1 in the subnet mask. बराबर है? Yes or no?
Yes, sir.
So that becomes to use a 0 at that position, that is the first block, and 1 on that position, that will be the second block. बराबर है? So whenever I put it here 1 in the first bit of the last octet, my two blocks will be 192.168.10.0 to 192.168.10.127. Second block 192.168.10.128, 192.168.10.255. So that is been 0 to 255 divided into equal portions.
Yes, sir.
Got the point? Is
Yes,
it
sir.
clear? So how many equal portions are required? 2 only. So 1 bit is sufficient. 1 bit shifting of host to network is sufficient. Yes or no?
Yes, sir.
Yes. Now let's suppose I want to divide it in the 4 departments of equal size.
Sir, is it possible to divide into odd number of departments of equal size? Like
Odd
3,
number
5.
of 3, 5. No, it should be in a unit of 2 raised to.
Okay.
So I will come to that problem. मैं बाद में आता हूं उसमें. ठीक है? अभी पहले ये पढ़ते हैं. 4 equal size portion, 4 department. कितने डिपार्टमेंट हैं?
4.
How many departments are there? 4. बराबर है. तो आप 2 के रेंज में, 2 raised to के रेंज में, how many bits required to represent 4?
64, 64, 64, 64.
मैंने क्या पूछा देखो. 4 डिपार्टमेंट है. So how many combinations of binary bits are required to represent 4 values? यहां पे मत देखो कहीं, मैं सिंपल पूछ रहा हूं. मुझे 4 नंबर रिप्रेजेंट करने हैं, तो मुझे बाइनरी के कितने बिट्स लगेंगे?
2.
2
2
bits.
बिट्स. 0 0 0 1 1 0 1 1. Yes or no? Are you getting? Hello?
Yes, sir.
Yes,
Yes, sir.
sir.
Yeah. So let's suppose this is what the allocated to me by company. I will not change this one. मैं उसको एक अलग कलर दे सकता हूं क्या? I will give something different color. बराबर है? And now let's start doing. I want to make it in 4 departments. So I will just add here one more. So let's do it in a 4 department. So 2 bits are required. Agreed? Agreed or no?
Yes, sir.
So can I do this? To कौन सा है? येलो कहाँ गया?
सर तो अभी ये नेटवर्क पोर्शन में चला जाएगा.
समझ में आ रहा है क्या मजा है इसमें? So this will become now. What you said here? What you said? कैसे 4 हो जाएंगे? नेटवर्क बिट्स में 2 बिट होस्ट के नेटवर्क में डालूंगा और फिर बोलूंगा 0 0, है ना? 0 1 बराबर है ना? तीसरा 1 0 एंड चौथा 1 1. वही लिखा मैंने सबनेट मास्क में. 0 0 देखो 0 0 0 1 1 0 and 1 1. I written this. Okay, let's do it. this is 0, this will be now, hello, क्या लिखूं यहां पे? These are the portions of दो बिट लिए ना
Zero,
सबनेट। so I sorry, I will just do some modification. Subnet masks are all one. Sorry, subnet masks, here it is, I want to say like, okay, subnet mask 2 bits I have taken from the host portion, so that will tend to me 0 0, this will become 0 and 1, this will become 1 0, and here it will become 1 1. Is this clear? In broadcast version, I will make the changes. In broadcast ID2, here it is value as 0, all others are 0. Here it should be written as it is, na? 0 1. Here it is 1 0. Here it is 1 1. क्या किया मैंने? What I done? 2 bits from the last octet I allocated for the network. बराबर है? So the first network will be 192.168.10.0 to 192.168.10.63. Is it okay?
Yes, sir.
Yes. Second, 192.168.10.64, 192.168.10.127. Third, 192.168.10.128, 192.168.10.191.
Sir, नेटवर्क
Yeah.
आईडी आईपी एड्रेस और सबनेट मास्क का ये है ना, एंड किया तो मिलता है ना?
Yes. Don't
So
leave it.
second
Currently, don't
department.
look at this. Currently, don't look at this.
Okay, sir.
Don't look at this. I will tell you later.
Okay, sir.
Okay, please allow me. Currently, just have the conception here. बराबर है? Whenever I am take the 2 bits from here, whenever I take the 2 bits, I will just remove this if you want. So there will not be any confusion. Yeah. Currently, I will remove this. Let's see now here. So what is the subnet mask now? 2 bits are taken from the host to network. So network ID will become as 00, 01, 10 and 11. So the start and ending portion will be start from 0 to 63, 64 to 127, 128 to 191, 192 to 255. Is this okay?
Yes, sir.
Is it having any doubt now? Let's suppose I want to divide it in, कितना करेंगे? 8 equal departments. तो क्या करेंगे?
और एक बिट ऐड कर देंगे।
3
और एक
bits.
बिट होस्ट का इधर चला जाएगा. सो कॉम्बिनेशंस विल बी 0 0 0, 0 0 1, है ना? Should I do that?
Yes, sir.
Yeah. Let me go here. So rather than now I am having 4. 4 होने चाहिए ना? 1 2 3 4. हाँ 4 है. So rather than 4, I want to have now 8 बराबर है. So what the combinations? एक और बिट मेरा होस्ट से नेटवर्क में आएगा बराबर है. So this much bits will be yellow and then I will start writing here. First is 0 0 0, so this will be also 0. This second one 0 0. अरे ये क्या हुआ? Yeah, here 0 0 1. To make this portion as it is 0 0 1. Then उसके बाद 0 1 sorry 0 1 0, so that will be 0 1 0. Hope you are getting this point. 0 1
सर
या
0 0 आएगा ना और फिर 1
तो
आएगा. सबनेट
0 0
मास्क का
0
उल्टा है ना, नीचे सेकंड थर्ड में,
इसमें
थर्ड में
इधर
सबनेट मास्क का 110 है तो
subnet
नीचे
are all 1.
001 आएगा.
Subnet are all 1 till 3 bits.
ओके ओके.
We have move one host bit portion to an subnet, na? So we have to make that till that bit all values as 1. Is it clear?
यस सर.
So what I am actually doing, I have taken 3 bits. To have a 8 departments, I should have 3 bits. So I written here as 0 0 0 0 0 1 0 1 0, है ना? अरे ये जा रहा है टेक्स्ट. I hope you are able to understand. 0 0 0 1 0 1 0 0 1. ये 3 हो
Yes,
गया.
sir.
Yeah, let's go to the 4. This is 4. Let's go to the 5 1. Sorry. 1 0 1 5. So here it will be again 0 1 5 6 7. That's it. So now the blocks will be starting from first block 192.168.10.0 to 192.168.10.31. Second 32 to 63. Third 64 to 95. Fourth 96 to 127. Fifth 128 to 159. Correct. 160 to 191. 192 to 223. 224 to 255. Same 0 to 255 into 8 blocks. Are you able to understand?
यस सर.
समझ में आ रहा है? Is it okay? This is known as the concept of subnetting. This is known as concept of an subnetting. Is it clear? Is this clear? Let's suppose now 2 departments, or we can say like 4 departments has vanished. So now again we have 4 departments only, but the number of hosts, so they are doing merging. 2 डिपार्टमेंट का एक डिपार्टमेंट उन्होंने बना दिया. So they have reduced the number of departments now. So what should we have to do in that case? नाउ दे वांट टू अगेन गो टू 4 डिपार्टमेंट. सो क्या करना पड़ेगा हमें?
पहले
We have
सबनेट
to
मास्क
shift, yeah, we have to shift subnet mask to. So क्या होगा? एक बिट हमें
0
इसमें देना पड़ेगा. सो उसका कलर क्या था? मैच हो गया. चलो, बराबर है. सो दिस वैल्यू बिकम 0. Concept of supernetting. Moving the host bits to network bits, that is known as the concept of subnetting. Moving the network bits to an host bit, that is known as the concept of supernetting. So from 8 again I goes to, है ना, मुझे सारे सबनेट मास्क चेंज करने पड़ेंगे. So as the subnet mask get changed, you can change here the value. So what will happen now here again? 2 bits 0 0 0 1. All other bits should be 0 0 1. Then 1 0 0 1 1. It should be 1. Any doubts? 0 0 0 1 1 0 1 1. Similarly, the last broadcast ID has to be get. Broadcast ID में क्या होगा? Host bits make it as 0, that will become network ID. Host bits make it as all 1, that will become a broadcast ID. First ID and the last ID. Is this clear? So that is 0 to 63, 64 to 127, 128 to 191, 192 to 255. Is this clear? अभी मुझे डाउट है तो पूछो. Anyone has any doubts here now? Hello? I hope I'm audible. क्या हो गया? Hang हो गए?
Yes, sir.
Yes, sir, audible.
No doubt.
Yeah. Is it clear now? Can we move to the slides? Now let's suppose I ask you one question, that to which block this IP belongs? 192, 168, 64. No, 64 is not possible here. 10 only. And here I can write something, let's say as 162. Can you tell me which particular block it belongs?
Third.
Simple. 162 कहाँ पे आता है? 0 to 63 में नहीं, 64 to 127 में नहीं, 128 to 191 में है. Yeah, it's there. So it is there. फिर आपका वो कंसेप्ट आएगा एंडिंग का. सो रिप्रेजेंट 192, 168, 10 एंड 162 यहाँ पे रिप्रेजेंट करो. कैसे करोगे? 128. अरे इधर का चला गया क्या? हाँ 128 कि क्या रिप्रेजेंट करना है 162 ना, 192 नहीं चलेगा। 32 अभी कितना बचा, 2। So can you tell me now 192 a block to which this particular IP belongs? So subnet mask देने के बाद, see what you have to do here now. You have to perform an ANDing operation. Keep these bits as it is and make all other bits are 0. So that will tend to an 128. So the block starting where this IP belongs is 192.168.10.128, and the block end to 192.168.10.191. So block is starting from 128 to 191. Is this clear? This is a block where the IP address 192.168.10.162 belongs. This is required everywhere. गेट एग्जाम, नेट एग्जाम, ये एग्जाम, वो एग्जाम, सारे में कहीं भी यहाँ पे नेटवर्क का क्वेश्चन आएगा, आईपी एड्रेसिंग का आएगा, वहां पे ये लगता है. Is this crystal clear? Any doubt till this point now? Can I move to the slides? Can you allow me to go there now? Hello?
Yes, sir.
Let me go here. So यहाँ पे ये भी बता देता हूँ. चलो अभी let time आ ही गया है. So what I will do, I will make a copy here at the last, and okay, let's start with the classes. Class A. Anyone knows about class A? Then we go for class B. Then we go for class C. Then go for class D. Class ABC are mostly required. बाकी तो आगे ठीक है. So if you observe in class A starts with value as 0, है ना, and ends at anyone? Class A ends at hello, are you with me?
Yes, sir.
So class A, whenever we talk about it, start from 000 and end to this one. First bit make it as 1. So in the class B, we are going to make the first bit as 1. बराबर है? Hello? First two bit make it as 1. All other bits are 0. Class C. -1. So that is the last bit will going to be an 191. So class A, if you talk about it, start from 0 till 128. Class B start from 127. उल्टा कर दिया मैंने, 1 मिनट. It starts from 128 end to 191. It should not be 1 here. Class C starts from 192. And ends at 223. Because class D starts with 1, 2, 3, 4. All other bits are 0. Ends at 240. 240, sorry. 224. Starts with 224. And ends at 240. Last, class E starts at I can say here. So class A going to start from 0 to 127. Class B going to start from 128 till 191. So I should put here as 0 and I will put here as all others bit as 191. I will do the same thing here. Put here as 0 and I will put बराबर है. Class C start with 192, ends at 223. Class D start with 224, ends at 239. And class E starts with 240, ends at 255. These are the different classes where the subnet masks are for the first class A, the subnet mask is single 255. For class B, it is double 255. बराबर है. For class C, it is triple 255. And class D, it will go on with the multicasting. 255. All the bits are 255. Okay, so can I say now it starts from 0 to 127. It's from 128 to 191. Just concentrate over the first bits. Class A, first bits we have to remove and make it as 0. Class B, first bit make it as 1. Okay, remove the first 2 bits. Class C, concentrate over the first 3 bits, first 4 bits. Like that we can able to easily segregate these classes. So let me go for the slides. The prefix length. So there is another notation. This is called one of the notation of writing this subnet mask, that is known as CIDR notation. So in this notation, rather than mentioning as 255, this 255 can be mentioned as /8. The double 255 can be mentioned as /16. So we can write for any IP address, let's suppose 192 168.10.10. Let's suppose it is belongs to class A, so I will write here as 8. Let's suppose it is belong to class C, so what should I write here? If it belongs to class C, what should I write here?
24.
24. Did you got this slash notation? Prefix length. The prefix length is going to indicate number of network bits. Number of network bits to be involved in the subnet mask, or with the number of ones in the subnet mask given by this prefix length. So that will total indication of network bits. So determining the network and the logical and, that is what operation they are performing here, and operation, so that they can able to perform or find out the network ID and the host ID first. That is, I don't believe in the AND operation. So are you want to do the AND? Once you understand clearly, you can easily able to do this. AND क्या कर रहा है? Number of ones in the subnet mask will going to decide number of bits from the IP address will going to be a part of IPv4 network. Number of zeros in the subnet mask will be as it is remain as 0 for the network. So that is first 3 octets as it is, that is 192.168.10.0 will become the network portion. बराबर है? Let's suppose this bit is 0. Can you tell me? Let's suppose this bit is 0. Can you tell me the network to which this particular IP address belongs? Last bit is 0, means it belongs to an host portion. This bit, it belongs to an host portion. So what will become an ID here? 192.168. क्या हो जाएगा? Hello? What is this?
9.
9 है? टेन ही है ना बाबा?
10 ही रहेगा.
It is a network ID ना. This will become a network. This is not, we can say as a, so this itself become a network 10 series here. कुछ ज्यादा कोई difference नहीं होगा यहाँ पे. Is this clear? Any doubt till this point? Let's suppose I make the 2, then 2 bit गए यहाँ से. Then it belongs to 8 series. 192.168.8.0. Is it clear?
Yes, sir.
ये 8 बन जाएगा. मैंने और एक बिट कम कर लिया. It isn't having much effect. मैंने और एक बिट कम कर लिया. Now it will be 0. It belongs to 192.168.0.0 then. Yeah, there is a video for you. So let's have a look at the videos so that you can be relaxed. Any doubt till this point? ये बहुत important है. Did everyone got this subnetting?
Yes, sir.
Just give me a time. I'm opening the video. Till that we will proceed further. Yeah, network, host and broadcast address. How we can able to find the network address, host address and the broadcast address. So this is a subnet mask given here. Network address is given as 192.168.10 because it is 24.
Sir, screen is not visible.
Okay. Just a minute. So let's suppose find out the network host and broadcast addresses in this particular domain. So let's suppose that they are given the network address as again same 192.168.10.0. So for the 10.0 now you should able to tell it is /24. They are written means first 3 octets belongs to a network. Yes or no? Hello? First 3 octets belongs to a network portion. The last octet belong to an host portion. So the first address will be 192.168.10.1. Last will be 192.168.10.254. Broadcast will be 192.168.10.255. That will going to be an broadcast. Any doubts about for this?
No, sir. So can
Okay,
you
then
please tell like, what that /24 exactly means?
/24 means number of bits from the subnets going to be in the network.
Okay.
So if I return here 26, इसका मतलब क्या हो जाएगा? 8, 8, 8.
And two from the
Bifurcation will
host
be here.
portion. Yes.
Is it okay?
Yes, sir.
So sending to one, that is called as unicast. Sending to a set, that is called as multicast. I hope you don't have any doubts about this unicast. PC1 sends a unicast packet to a printer, that is 253. So it is sending to one particular destination. Sending to broadcast packet to IPv4 host, that is known as broadcast. That is called simple switching. So if you observe here, hello, destination is all 255. So that is called, we can say, the broadcast address. Then here multicast to set of groups. So these two PCs will not get this information. Only the PCs which are a member of that particular multicast address will get that particular message. That is called unicast, broadcast, and multicast. Types of IPv4 address public and private. So these are the ranges been defined for the private. So this is RFC 1968. That is by using IANN, which define the numbering scheme of our IP addresses. Okay, so this been defined here as for the private IP range. This is very much important. Please, 10.0.0.0 to 10.255.255.255. That is all we can say the private class A private, we can say, or whatever private address. 172.16 to 172.31, that is class B. 192.168 to 192.168 255.255, that is class C. So these are the sets of private IP addresses. So majorly all examples which you are going to see, you can see from the series of 10 or 192.168 or 172. Mostly these two are preferred. Examples will going to prefer these private IP addresses. So there will not be any mistake. Once you are written 10 or once you are written 192.168, whatever you return next, that will be belongs to private. So there is no confusion. So that's why most of the examples are considering these two numbers for giving an hands-on. Is this clear about the private range? So NATing, what's the use of NATing? Network address translation, any idea? NAT allows and one public address to be shared among the devices present in our local network. That is known as concept of netting. So the private IP address 10.0.0.8 is valid in this network 1, but it is not valid here. So this address, whenever go outside that particular perimeter, it get converted to an public address. And that is what the concept known as netting. Translate the private IP address to public IP address. That is what the exact meaning of netting, network address translation. Why netting? समझ में आ रहा है? Private IP address are at all doesn't have any validity outside the network. So to make available or to know the or to have an identification of the packet outside this particular local network, we have to have an public IP. So mapping of private to public is done by the router. That is not the concept of NAT router or netting. Concept of netting. Hmm? Hmm. Edit वर क्लिक करायचं. पाठ टेकून बस. Is this clear? Netting. Loopback addresses, that is 127, are referred as loopback addresses, and 169 series are referred as link local or also known as APIPA. Whenever the DHCP address is not able to get allocated or DHCP fail to assign an IP address, at that point PC automatically considers his own IP address from the range of 169 to 54. That is known as automatic private IP addressing, that is APIPA. Okay, so whenever Windows DHCP fail to assign an IP address, the PC automatically himself gets an IP address that is known as 169.254. Any doubt till this point? Let's have a look at the video so that you can just tell me if you are able to listen or no, audio is on or not.
All devices on an IPv4 network need a 32-bit
Is it audible?
logical address in order to communicate.
Yes, sir.
The 32-bit logical IPv4 host address consists of a network portion or network ID on the left and a host portion or host ID on the right. The length of these depends on the size of the network. Larger networks will have a longer host portion. A network can be thought of as a range of addresses. All devices on the same network have the same bit pattern for their network ID, but they will have a different host ID. Some addresses in this range are reserved and have a special name and meaning. For example, the first address in the range is used to identify the network itself and cannot be assigned to any host. It is referred to as the network address. The last in the range is called the broadcast address and is used to send a message to all devices on the network at once. It also cannot be assigned to any host. All the IP addresses between the network and the broadcast addresses make up the usable or valid host range and can be used to address a host on the network. Let's take a look at how these addresses are determined. In order to forward data, a device needs to know what network it's on. Using their host IP address, their subnet mask, and a process called binary ANDing, a device can find what's referred to as the network address. This address represents the network to which the host belongs and will be slightly different than its host IP. To do this, the device compares their host IP and their subnet mask bit for bit. If the bit values are both a binary 1, the result is a binary 1. If one or both of the bit values is 0, the result is a binary 0. Let's take a look at an example. Let's say we have a PC with a host IP address and a subnet mask of 192.168.2.38/24, and we'll use ANDing to find the network address of the host. Here's the host IP in binary. Here's the subnet mask in binary. If we compare them bit for bit, we can see that a 1 and a 1 results in a 1 and a 1 results in a 1, a 0 and a 1 results in a 0, a 0 and a 1 results in a 0, and so on until we have compared all 32 bits. Notice that the last octet is all binary zeros. Because we are using a /24 subnet mask, the first 3 octets represent the network portion, and the last octet is the host portion. Network addresses will always have binary zeros in their entire host portion, however long it is. In this case, the last 8 bits. If we convert to dotted decimal, we can see that this host belongs to the network 192.168.2.0/24. Now let's determine the broadcast address for this network, which is used to send a message to all devices on the network at once. Whereas the network address had all binary zeros in the host portion, the broadcast address will have all binary ones. Since the host portion in this example is just the last octet, to determine the broadcast address, we keep the network portion the same and change the host portion to all binary ones. This results in a broadcast address of 192.168.2.255. Next, we'll determine the usable host addresses, which lie between the network and the broadcast addresses. The first usable host in binary will be all binary zeros with a binary 1 at the end of the host portion. Converting to dotted decimal, this tells us the first usable host on this network is 192.168.2.1. Lastly, we'll determine the last usable host, which will be all binary 1s with a 0 at the end, the opposite bit pattern of the first usable host. Converting to dotted decimal, we get 192.168.2.254. Let's recap our calculations. We began with the host IP address of 192.168.2.38/24. Using binary ANDing, we determined that this host belongs to the network 192.168.2.0. Keeping the network portion the same, but placing all binary ones in the host portion, we determined that the broadcast address for this network is 192.168.2.255. Again, keeping the network portion the same but changing the host portion, we determined that the usable host range for assigning addresses to devices on this network is 192.168.2.1, which is one number up from the network address, and 192.168.2.254, which is one number down from the broadcast address. You can see that our original host IP address falls within this range. Things to keep in mind when working with IPv4 addresses. All IPv4 host addresses are 32 bits in length. A portion of the address represents the network that the host belongs to, and that starts at the left. The remaining part is the host portion, which identifies the host on the network. And there are 2 special reserved addresses on every network that can't be assigned to hosts. One is the network address, which is the lowest in the range of addresses and represents the network that all the devices belong to. And the other is the broadcast address, which is the highest address in the range and can be used for a shout out to all devices on the network at once. Thankfully, there are shortcuts you can take for calculating these addresses without having to convert to binary first. But examining these addresses at the bit level should help you understand how network devices interpret them and also how the dotted decimal format is derived.
Just wait, I will just check it out, the other video which I have to show. I will check from the slides. There are no video. Let me go for the next. So let's fastly we cover the other activities. This is so. Is it clear about the APIPA? Let me go for the next. That is the classes: class A, class B, class C, and class D. So as I told, class A starts from 0 to 127. Class B from 128 to 191. Class C from 192 to 223. Class D from 224 to 239, and class E from 240 to 255. So these are the, we can say, different classes. There is no other concept of classful addressing. Hello, all are there? Hello?
Yes, sir.
Yes, sir.
Yeah. So then this is what we can say IP assignment. So there is an authority that is says Internet Assigned Numbers Authority that will be responsible for regional heads and the allocation of the IP ranges for the respective ISP providers. Let me say as a network segmentation. So broadcast domain and segmentation, we have to consider the only device which can stop the broadcast messages is an router. So even the switch can't able to stop the broadcast message. Switch can have different collision domains, but they cannot have the different broadcast domain. Broadcast domain can be stopped only by the router. So what do you mean by the broadcast domain? All the broadcast packets will not go beyond this particular router. So this will be limited to this region only. So that is what referred as a broadcast domain. So most of the time the broadcast or multicast address are required for the DHCP. So any particular, whenever PC connected to this particular switch want an IP address, so he will go for an broadcasting and DHCP discovery. So for that particular time, he will go as a broadcast domain. Okay, so this address, this DHCP discovery will not go beyond this router. So that is called restriction of the broadcast domain. So if you have a large broadcast domain, we will not segment it. So what will going to happen? Excessive broadcast will be generated and that will going to hamper unnecessary traffic. So it might be possible that even though you are searching for, let's suppose, one particular user from this 400 users, all will be get hampered. Full traffic will be get hampered for 400 users with this particular searching for one IP addresses. So that's why it is better to go for having a limited IP addresses. That's a simple thing. Rather than announcing from the first floor for all the students, let's pass on the message to all the HODs of every floor, and then from every floor we can have an announcement for the student. That has always been better. So that is nothing but the concept of reducing the broadcast domain. That is one of the example, the reason of segmenting a network. So here we can easily able to say there are two reasons. One, we can say the location demands to have an segregation, or second, the group or functional wise. So we can say the floor wise we can have an differentiation of the networks, or even we can say finance network, administration, students, accounting, like that. Functional wise also we can able to segregate the network. So here they are given the example of segregation. Where you can easily observe that floor wise they are tried to allocate the IP address range. So first 10.0.1, 10.0.2, 10.0.3, 10.0.4, 10.0.5, like that. That location wise they are done the different subnetting. So what will going to happen now? Whenever from the internet any packet will be there, based upon an map, respective map private IP addresses, let it can be, let's suppose 10.0.3.0. Now we have to find out this particular PC present at which location, what the exact thing will be done. Anyone? Where the broadcasting will be done? broadcasting for searching of the PC 10.0.3.10 will be done on where? Whether it will going to broadcast to all floors? Is it going to broadcast to all floors? Hello? Hello? अरे
Yes, sir.
चले गए क्या सब?
No, sir.
Come back, come back. Last one problem and we will finish this module. Tell me just example. From the internet, we have received a packet for 10.0.3.10. To which floor or to all floor it is get broadcasted to search this PC? I want to search the PC 10.0.3.10. Broadcasting is done at what place? All the floors? Which? Hello? Where it is get broadcasted? Is it get broadcasted to all the floors?
Sir, to a particular floor which is having the subnetting of.
So which floor? So if you observe here, यहाँ पे नहीं दिख रहा है.
No, sir. थोड़ा.
Is it okay now?
Yes, sir. So it will be transferred to that third floor. From
Third
what?
floor. It will be here to LAN number 3. So it will goes here. Okay. So that is what we can say the concept of segmenting the network. I hope it is clear to you. Subnets and IPv4 address. So there is a simple way of doing. Yeah. Any doubt? Hello.
No, sir. No.
Yeah. So the prefix length is going to decide us what? The network portion and the host portion. So prefix length 8 means 8 bits of the subnet mask are belongs to a network. 16 means 16 bits of subnet mask belong to a network. 24 means 24 bits are belong to a network. So this is one of the example by which we can able to have an octet boundary. That is the division in terms of an boundary wise. So we can say like if we want to divide it in equal, that is known as the concept of equal distribution. But is the equal distribution is always the right way of doing the things? Is the equal distribution is always a right way of doing the things? That we have to find out today. So let me go for first this. So if we talk about here, yeah, what is this? In the first table, 8 is subnetted using 16. Means क्या किया उन्होंने? We have the allocation of 8 subnet masks. We are divided into, hello, 16. बराबर है? Means the allotted IP address is 10.0.0.0. So how many equal portions we can able to divide? So we can say, let's suppose if I have taken complete one octet. So what will going to happen? It starts from 0 to 255. The starting address is 0. Last address is 10.255.0.0. Is this clear?
Yes, sir.
Yeah. That is what just they are just shown here how we can able to do this stuff. Nothing else. If you go for again 24, how we can able to do? That is what they have done for that 24. So if the 24 is there, then it starts from 0 to 255. Again, third octet 0 to 255. So that is what we can say the range is being divided. So one of the example that is subnetting at the octet boundary. Let's 6 ways to subnet a 24 network. Again, allocation is 24. So either we can add 1 bit from the last octet. So that will become, so क्या किया हमने यहाँ पे only 1 bit added. Number of subnets can be created by 1 bit is 2 subnets. If you allocate 2 bits, 4 subnets. If you allocate 3 bits, 8 subnets. If you allocate 4 bits, 16 subnet. If you allocate how much? 5 bits, 32. 6. Is it clear? Any doubt about it? How many bits are added? अभी जो हमने किया वही उन्होंने लिखा है यहाँ पे. Is this clear?
Yes, sir.
So there is a video. Should we go for video or a problem? Let me go for a problem. We will see the video a bit later. This is one of the example of /16 prefix. So we can go on dividing it. So they are given one example. So if we have 172.16 IP address given in the range /16, then this much number of host bits are there. So if we borrow 1 bit, बराबर है, number of subnets are 2. Like that, how much we can able to borrow? So last is how many bits we can able to borrow? We cannot go for last 2 bits. Hello? थक गए?
No, sir.
Yeah. Just they are saying how whenever we borrow the bits, how much subnets we can able to create. That just they have defined by this problem. So one of the example they are given here. Subnetting to meet the requirement. So let we go for this. So number of individual subnet needed and number of host address required. That is what just given whenever we go on increasing how it has been done. We will take a problem and we'll see this. Efficient IP. Let me talk about one particular problem. So if you talk about here diagram, yes, on this particular diagram, how many subnets are required? This is a different diagram. The one private IP address, second private IP address, third private IP address. This is fourth, this is fifth, this is sixth. So how many networks are required? 1, 2, 3, 4, 5, 6. Agreed? DMZ. Yes, here come to this particular diagram. If you observe here in this particular diagram, there is an IP address given here. What is the IP address given? 172.16.0.0/22. This is what the IP address they are given for calculations. बराबर है? So number of host portions here 22 they are given. So 22 मतलब कितना हो गया? 8, 16 plus 6. So 6 bits of the third octet belongs to network. Last 2 bits belongs to an host portion. So now whenever we have to do an subnetting, we can do the subnetting only in this last. Hello? Only in
Yes.
this last 10 bits. Total 32 bits are there. 22 are network portion. So available for my subnetting are 10. Available for my subnetting are 10. Now let me understand how many subnets are required. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Agreed? समझ में आ रहा है? You cannot have this subnet as per this subnet. There should be a separate subnet from ISP to this edge router. Public यहाँ पे होगा अलग, यहाँ पे अलग है. So there can be total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 subnets are required. How many subnets are required? 10.
10.
बराबर है? So 10 subnets can be taken from how many bits? What is the closest number that will be represented into 2 raised to x portion? 2 raised to 3, 8. Not sufficient. 2 raised to 4. 2 raised to 3 is less than 10. 2 raised to 4 is sufficient for 10. So we have to go for 4 bits. So 4 bits of this we have to go for network. Agreed? Four bits from this we are going to add into a network. Agreed or no?
Yes.
Yes. Okay. So what are those particular values? 4 bits. Can anyone tell me now? Yes, यहाँ पे लिख दूं. Let's suppose I am talking about the 4 bits dot 00. Can you write that all 10? कितना हो गया? 1 2 3 4 5
8.
6 7 8 9 10. ये ऑक्टेट डिफरेंस है, वो याद रखना. This is last octet, this is third octet, and this is fourth octet. So this is the position as 2 raised to 6 and 2 raised to 7, and this is 2 raised to 0 and 2 raised to 1. बराबर है ना?
Yes, sir.
Yeah. So how we can able to write now? The first will be according to this 172.16.0.0. That will be the first. What will be the second? Can you tell me? 2 raised to 6. बराबर है ना? 2 raised to 6 64. 2 raised to 7 128. Third, should I go to Excel sheet? 128. हाँ? Hello?
Yes.
Fourth? Yes, किसके लिए? मुझे समझा नहीं.
192.
192. Then 172.16 dot, यहाँ पे 0 है, यहाँ पे 1 है. 2 raised to 0 position is 1, so that is
1.
1.0. 172.16 dot 1 dot 64. Agreed? 172.16 dot, यहाँ पे 1 dot 128. 172.16 dot 1 dot 192. 172.16 dot, बोलो क्या लिखूं? क्या लिखूं? This is 2 raised to 1.
2.
Correct.
Dot 0.
2.0.
64.
Yes. ठीक है. अभी आप देखो इसमें क्या है. Are these all addresses 172.16.00, 172.16.0.64, 172.16.0.128, 172.16.0.192? बराबर है. उसके बाद ये खत्म हो गया. फिर 172.16.1.0, 172.16.1.64 वापस शुरू हो गया. 1 सीरीज शुरू हो गया. 172.16.1.128, 172.16.1.192, 172.16.2.0, 172.16.2.64. That is was the last one. This is the last. 10 के 10 allocate हो गए. But are these equal? Are this size are equal? Matlab, how many hosts are present in this each block? Can you tell me?
$64.
Yes. Each block is having 64. Is it correct? बराबर है ना? 8 में से 2 गया, that is 2 raised to 6, that is 64. How many allocatable host IP addresses present in each block?
62.
62. 64 minus 2, that is 62. Allocatable, because 0 network and 64 will be broadcast. 63, sorry. 0 network and 63 will be broadcast. So 2 gaye 64 में से, so that will be 64, that is from 1 to 62 we can allocate to an host. Is it correct? Is this clear? Everybody?
Yes.
कितने लोग हैं मुझे नहीं पता. Is it okay now? Can I move to the next?
Yes, sir.
Yeah. Yeah. So now I come to the question. I want to ask you one question. Is this way of doing an subnetting is efficient way of doing it? Efficient mean to say, like I agreed, it might possible that this network inside might require 62. यहाँ पे 62 चाहिए, यहाँ पे 62 चाहिए. I agreed. Is 62 required here also in between? यहाँ पे भी 62
No,
चाहिए.
sir.
So all west हो गया कि नहीं?
Yes, sir.
Yes. That's why they suggest that according to requirement we should do the subnetting. यहाँ पे 64 चाहिए, इनको 64 दो, लेकिन यहाँ पे सिर्फ 2 ही चाहिए. Then why you are giving them again and 64? What is the waste of IP address scheme? That's why we are going for an concept known as VLSM, variable length subnet mask. Concept of an VLSM. I have given one example here. Let's suppose how many networks required here? Here is 1, 2, 3, 4, 5, 6, and 7. 7 networks required. So if we allocate here 3 bits. Hello? So what is going to happen here? What they have provided, given a topology, 7 subnets are required, 4 LANs and 3 for the WAN links. 4 LANs and 3 for the WAN links. If we do the same way which we have done previously, बराबर है? Can you tell me, let's suppose A27 is a mask. 27 matlab 3 octet and 3 bits from the last octet. Yes or no? So it starts from 0, then 32, 64, then 96. बराबर समझ में आ रहा है? 3 bits. Hello? Hope I am audible.
Yes, sir.
So this is what we can say divided in 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. एक कोई तो रह गया. Last we will remove. Last are still available. So we can say now we can allocate 190 to 168, 20 here, 20.0 here, 0, that is 32 here, 64, 32 here, 64 range here, 96 range here, 128 range here, 160 range here, and 192 range here. Let's suppose the required number of hosts are there in 25, 20, 15, and 28. How many hosts are available here? How many hosts are available here? 32 hosts per block. So the number of waste here will be 7. Number of waste here will be 12. Number of wastage here will be 17. Number of waste will be 4. Can you tell me the number of wastage here required are only 2. So 30 are waste. Agreed or no?
Yes, sir.
So this is waste. This is complete waste. Not required. We will require only 2. बराबर है? So for that we will go for variable length. So in the variable length, what we try to do, so if they are given here, so we have 30 host IPs are available. 30 minus 2 for ynet 2 requires, so 28 addresses will be wasted at this particular point. So to avoid it, we will go for an VLSM. So rather than doing, so what exactly we are doing here in VLSM, we will divide one particular subnet into more subnet mask. So what we can do here, rather than going for having a selection of, we will go for the last octet. So we will go for last one. What is that? 111. So that is कितना होता है देखो, 128 plus 64 plus 32. Can you tell me this value?
224.
224. So we will talk about the block which is going to start from 224. So the subnet mask will be 111 0 0 0 1 2 3 4. Okay, let me talk about this last octet. How many subnets we want here? 3 subnets only. We want 3 subnets for the 3 WAN. Hello? Hello?
Yes, sir.
Yeah. So how many bits from the host we require to add in the network to have 3 more subnets in the 224 series? We are talking about this last. मुझे 3 सबनेट चाहिए, 1 2 3. 1 bit can give 2 na number of binary bits.
Yes, 2.
So 3 will be 2 raised to 2. It will go to 2 raised to 2 bits. So 2 bits of this I want to shift it to an network. Hello? Yes?
Yes, sir.
Yeah. So what will going to happen now here? 1 1 1 0 1 1 0 1 1. So can you tell me now? 224. This is known as 224. So first will be 224. Second, how much I should have add? What is this position? 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to
3, 8.
कुछ गड़बड़ हुआ यार. 1 2 3 4 5 6 7 8 4 5 6 7 8. That is correct. Yeah, 8. So that is 224 plus. Sorry, this is 224. 0 0 0 1 1 0 1 1. Yeah. 224. This is 224, na? So rather than 27, yeah, I will do in a reverse way. So this will again waste more thing. Still there is a wastage. How many number of hosts are required? We'll do in some another way, different way. Sorry. So let me talk about 192.168.20.224. That is /27 hai. We are talking about this particular block. We want only 2 hosts. So the two hosts, I required two host bits. Is it okay? So
Yes, sir.
last octet, I will go to last octet 1, 2, 3, that is 224, 0. Only two host bits are required. I don't require more than that. बराबर है? If I go on with the subnet mask, what will happen? Still there are wastage of host bits. Whenever I add here from subnet mask, required number of 4 subnets are required. Then total 7 hosts are available, and each block again required are 2, wastage is 5. So whenever there is a concept of reducing the waste of host IP addresses, we will just go with the concept of number of hosts required and then do the subnetting. समझ में आ रहा है? Whenever we are in a concept of reducing the wastage of host IP addresses, we will go with the right side, rightmost side. That is, let's require how many hosts required? 2 hosts required. So that is available is 2 raised to 2, that is 4. So I will use only 2 bits in the host portion. So the subnet mask will become 30. Subnet mask will become 30. So the second subnet will be 1. Can you tell me now? Zero, 1, 1. What is this 224 plus 4? So the first is here 224. Second, 224 plus 4, that is 228. This is 4, na? 2 raised to 0, 2 raised to 1, 2 raised to 2. That is 4. Then add 8 into 2 to 4. That is 232. Then 8 plus 12. है ना? 8 plus 4. That is 12. We have to add in 2 to 4. That is कितना हो जाएगा? इसमें 12 ऐड किया तो
236.
236. How many we required? Only 3. So we can allocate here. So if you concentrate here now, the first, that is 224. Second, that is 228. Third, 232 we are given here. All others still are vacant. Is this clear? That is what do you mean by the VLSM? All others still are vacant. Is it clear? So from 236 onwards are still available from the block of 2 to 4. From the block of 2 to 4. This is known as VLSM. Is this clear? Is this clear, this diagram?
Yes, sir.
All are clear with it? So end user device address assignment, that is gateway, it's okay. We will see one video where we can have a problem and we'll try to solve that problem. There is a problem in VLSM. You want to see the video of VLSM or directly go to the example?
So directly example.
We'll go directly for an example. Just tell me you're audible or no.
In this scenario, the task
Yes, sir,
is
audible.
subnet the 172.16.0.0/23.
One more question. This is what the problem. Should we go with the Excel or you want to see the audio? or we will first solve with the Excel, then we come back to video this. You can see the
Okay,
video
sir.
at your
That will
own.
do.
Ah,
Okay, sir.
so
Excellent.
let me go here. I will write the problem. What is given? Yeah, sorry. Yeah. I will do it in some way, entire screen. Yeah. So what is given? 172.16.0.0/23. 172.16.0.0/23. This is what the things are given. Is it okay? अच्छा शेयरिंग बंद हो गया. Just a minute यार. अरे कहाँ गया? Why is not able to share? Sorry, I have taken more time for a few. So this will be the last example, and we will stop today. So this is what they are given. What's next things are given? First network of 200, second of 200, 50, 25, 10, and 4 of 2. So I will just write here. We want one network of 200, one of 100, one of 50, one of 25. Let's everybody concentrate here now. So last one of 25 और क्या है? 10, one of 10, and 4 of, please have a look, 2. 4 of 2. Host I should write. Is this clear? Any doubt till this point?
No, sir.
Yeah. Can you tell me available number of hosts for that company? 23 है. 23 है मतलब क्या हुआ? What do you mean by 23? How many number of hosts are gone? It start from, how can I write here 23? So it is start from 172.16.0.0 to कहां तक जाएगा? बोलो. Need a help? Let's go here. /23 मतलब first two octets no change, so it is 172.16 88 to 88 16. From last 3 octets how many bits?
7.
1 2 3 4 5 6 7. Last will be 0, and here again 0. So how many host bits are available here? How many host bits are
9.
available? 8 plus 1, 9. So that is number of hosts are, hello, 2 raised to 9.
512.
Yeah, that is 512 are available. 512 are available. Now, how many subnets we can able to divide it? In how many subnets we can able to divide it? That is what the second thing we can able to do. We can able to ask. Okay, let me go for now our Excel sheet. So you, according to you are clear now very much with the thing. So total available hosts are 512. Total available hosts. Now you have to tell me now here how much total host IP host addresses I should allocate here. Are 200? Can we allocate just 200? Is it possible to allocate 200?
No.
Then
In the multiples of 2.
yeah. So what it be?
Yes, sir.
What about this?
2. 1. Can
2 hosts are required.
you
2
need
plus
1
2.
bit for it.
मतलब 4 होस्ट हो जाएगा ना. 2 bits. How many hosts will be there?
4.
Huh?
Using 2 bits, 4 hosts can be there.
Yeah, how many number of hosts? But अरे शेयरिंग वापस बंद हो गई, क्या हो रहा है? You are able to see?
No, sir.
Yeah, already solved. I have. Should I gone through this or should I write there? मैंने किया हुआ है ये सब.
So we should write there.
Okay. So that is 16. है ना? 4 in each.
Yes, sir.
That is 16. So how many total required? Exact 512 available, 512 will be get utilized. Is it correct? 512 are available, 512 are required. Is it correct? Let's start the work now. So from here, now we have to do the subnetting in these bits. You have to do the subnetting in this particular bits. What is the first requirement? What is the first requirement?
256.
256 means last full octet.
Yes.
Yes or no? Last full octet. So what should be this value? So I have to go for 24 here now. So this bit will be a network portion which splits this into two parts. One 172.16.0.0, another 172.16.1.0. बराबर है कि नहीं? दो में हो जाएगा. So can I write here? I will write here as so this will be divided as 24 and ये क्या हुआ? Yeah, 172.16.1.0. Agreed? Any doubt till this point? So what has been used here? Let's suppose we have used 172.16.0.0/24. We will utilize here. So what is available for us now? So I will say this will be utilized. So what is the range available with us now? What is available with us? 172.16.1.0. We cannot go for 0.0. Yes or no? Hello, all are with me?
Yes, sir.
What is the used IP? All कितने connected है मुझे पता नहीं है. All I want to answer now. Used IP, that is starting from, can you tell me? 172.16.0.0 to 172.16.0.255. These all are used to achieve the 256.
Yes, sir.
Yes, sir.
Yes. So we cannot go for 0.0 now. We have to go for 1.0 for splitting. Yes or no? Hello?
Yes,
क्या हो
sir.
गया? Yeah. So let me go for next further. So now we are going to split 172.16.1.0. That is currently 24. Now I want, what is the requirement is 64. 64 means number of bits are 6 bits. So 6 bits from the last octets required. For host, 1 bit belong to a network. 1 bit belong to a network. Is it clear or no? So this 172.16.1.0 splits in 2 portions by having value as 25. Hello? Is it clear? Is it clear? In the last octet, I shifted the first bit to a network, last then 6 bits to an host. Let's come to an Excel. So I can write here as available will be 172.16.1.0 slash 25. We will divide as and 172.16.1 dot for the second. Is it clear? The two addresses where it is get divided is, the first is 0 itself, second is, this is 2 raised to 7th position. First is 0, second is 128. Agreed or no? So the IP, this is 172.16.1.0. This is the starting address. For this it is 172.16.1.128. That will be a second block starting address. Is this clear or no?
Yes, sir.
All of you clear?
सर ये नेक्स्ट लेक्चर से स्टार्ट किया तो चलेगा क्या? समझ रहा नहीं है
Video.
फिलहाल, कुछ हैवी हो रहा है बहुत.
Okay. So this last point we will cover in next lecture. That's not a problem for me. So we'll take this problem again in this lecture. Okay. Hello.
Yes sir, yes sir.
Okay,
Yeah.
sir, will do.
What we can do then? What is your responsibility to have a look at videos present in this particular 11th module? And if any one of the video, if you want to explain me, I will explain in the next lecture. Otherwise, that videos are not required. We will solving the problem itself here. Is it okay?
Yes.
Yes, sir.
Yeah. So what should we do? Saturday we are going to meet.